In this video, I will be discussing the functions of the various knobs or thumb wheel on the MFP 3D head. The MFP 3D head houses the optical detection system and actuators that control the Z-piezo movement of the cantilever. The optical detection system is used to measure the bending of the cantilever as it responds to surface interaction forces on the samples. This animation explains how the optical system works. A laser shines a beam of light onto the back of the cantilever. A lens focuses the beam of light at the lever. The light reflects off the cantilever and up to a recalmation lens and mirror to the position-sensitive detector, a segmented photodiode. The photodiode is segmented into 4 quadrants. A voltage is generated from each quadrant that is proportional to the amount of light hitting it. The deflection signal is the difference between the voltages generated in the top and bottom halves of the detector. Typically, the light source is aligned, so the spot hits the center of the photodiode when the cantilever is far from the sample surface or undeflected. When the cantilever experiences an overall repulsive force, as when it pushes down onto a hard surface, it deflects upward, and the spot moves up the detector. More light hits the top half than the bottom half of the photodiode, so V top is greater than V bottom, and the deflection is positive. When the cantilever experiences an overall attractive force, as when it pulls away from an adhesive surface, it deflects downward, and the spot moves down on the detector. More light hits the bottom than the top, so V top is less than V bottom, and the deflection is negative. So to ensure the fidelity of your data from the AFM, it is critical to calibrate the equipment. Specifically, in this case, ensure that the laser spot is well placed on the cantilever and the reflected light from the cantilever lever is more or less at the center of the photodiode. You can monitor the movement of a laser spot through the CCD camera incorporated in the MFP 3D head. To adjust the location of the viewing field of the CCD camera, use the X and Y translation knobs on the back of the optics housing. To adjust the CCD image focus, use the thumb wheel in the optics housing on the back of the head. The LDX thumb wheel moves the laser spot along the length of the cantilever as indicated on the labels on top of the MFP 3D. The LDY thumb wheel located at the back of the head moves the laser spot across the cantilever. The desired location of the spot is towards the end of the cantilever to maximize the optical lever sensitivity. When the spot is at the base of the cantilever, the optical lever sensitivity decreases. The PD thumb wheel at the left side of the head adjusts the vertical deflection on the position-sensitive photodiode, PD. Usually, the deflection meter on the screen will indicate deflection when the cantilever is undeflected or far away from the sample. You will have to zero the PD. In the deflection meter, blue color indicates negative, so turn the thumb wheel towards the positive sign to zero the PD. Red signifies positive, turn the PD thumb wheel towards the negative sign to zero the PD. Finally, the large knobs on the MFP 3D head raise and lower the cantilever and the entire MFP 3D head in the distance to the sample. Turning the knobs clockwise raises the cantilever and counterclockwise lowers it. In the next video, we will be looking at the MFP 3D software GUIs and the monitoring meters.